Hello everyone, this is ECE100, class number 7. Today we're going to talk about oscilloscopes. So what is the motivation behind this topic? Up to this point, you only uh, dealt with DC signals. DC signal does not change with time. But in reality, as an engineer, especially electrical and computer engineer, deal with a lot of signals that changes with time. To visualize the signal that changes with time, we need special equipment to do that. And oscilloscope is a very unique equipment to visualize any time varying signal. What are the examples for time varying signals? Like audio tones, radio signals, TV signals, computer network, Ethernet, Wi-Fi, Bluetooth, etc. Intracomputer memory bus, PCI bus, and also AC power signals. All of them are time varying signals. To know the signals, to analyze them, we need to visualize them on a screen, and that could be done by using an oscilloscope. So, what type of signals I'm talking about, like time varying signals? So let's try to draw one here, if I can do it. So let's say this is maybe your voltage, this is time. So if you have a signal something like this over here, so this signal, as you can see, that it's changing with time. So this is the time over here going this way. The signal is changing with time, so we call it time dependent signal. So if you look at the signal, what kind of question comes to mind? Any signals that had the amplitude, right? So what is the or magnitude to call it? What are the amplitude and magnitude of the signal? And clearly that magnitude changes over time, right? Then what are the peak values? So this is called, what here is peak value right here. So this is called B peak. So we can have, what is the peak value? There's another peak on here. If we call it negative B peak. Then if you have two peak, then you can see that what is the peak to peak value. So we can also find V peak to peak value, right? Then this signal, if it repeats, then how often it's repeating? That's called frequency. So then you can also see, so magnitude, peak value, peak to peak value, and if it repeats, that's how often they're repeating, that's called frequency. Then also period. So all those things from a signal can be measured and visualized using an oscilloscope. Let's say it over here. So period, frequency, mean value, max value, peak to peak value, and all other parameters can be visualized using an oscilloscope. So for oscilloscope, one of the very important features is the trigger. What is the trigger? So your time varying signal coming to the screen of the oscilloscope is time varying, right? So it's always changing. So how do you make that signal stabilize on the screen? That is called trigger. So trigger is, you define the trigger with time and also a moment of the signal to take a snapshot. So when that moment correct, you take a snapshot and keep the snapshot on the screen until the next moment come in. So every moment is true, you take a snapshot and that you visualize the snapshot on the screen. So that is the trigger. So trigger, how often you trigger your oscilloscope, that depends on how quickly your oscilloscope can take a snapshot. That means the depends on the frequency of the oscilloscope. So again, nowadays most oscilloscope, I think almost all of them nowadays are digital, and that means they have the higher frequency limit. They can take the snapshot quicker than your analog one we have to use like 20, 25, 30 years ago. So to get a very good with the oscilloscope, you have to use one. We have plenty of them in the lab, and you have to use one and try to see how can you do a very good job with the oscilloscope to visualizing signals. And oscilloscope also has the capacity to basically visualize the transient behavior of the signal. So this is the one we're using in Kingsley Engineering Center lab 126. You see that there's a on a button here. Then we're gonna talk about all the novelology of this oscilloscope, and we're gonna do them lab in the class. We have a tutorial on the oscilloscope. So on the bottom there, then these are called the probe. So this is 2 channels for the oscilloscope. Some oscilloscopes have more than 2 channels. Like we have some of them in other labs has 4 channels. So probe, that means that you're basically measuring the signals using this probe. So probe 1 and probe 2. This one here is a how to adjust your signals. So you can adjust them, the magnitude using these knobs over here. So these knobs will give you the adjusting the magnitude of the signals. And these knobs over here will adjust the timing scale of the signal. So previous one, if you go here, you're adjusting the magnitude for with this one, and this one you're adjusting the timing scale of the display. And these are the auto scale. If you press the button, that means your signal will be scaled automatically by the oscilloscopes. Then the soft key over here, if you press that one, there's the menu come up on the screen, so you can adjust and also you can measure different parameters of the signals using the soft key. And this is the trigger we just talked about. This is the trigger. How do you want to trigger a signal? You can trigger the leading edge, falling edge, or you can trigger the both edge, and so on. So you can define how do you want to trigger your signal and what moment you want to take the snapshot. And the waveform over here. If you want to acquisition and display settings of the waveform, you can basically use these 2 buttons to do that. That what does mean that how we want to waveform, like you want to do an average, or you want to do instantaneous, or you want to do what kind of average you want, like that all can be done by these 2 button there. And cursor is very measurement is very important topics. You can try to see timing between 2 points on your screen, or you wanna take magnitude between 2 points on the screen. You can of the signals. You can use the cursor to do that. Then finally, you can save your signals to USB. So you can use these buttons and this USB port here to save your work to USB drive. Then you can put it to your report. And here's the signal over here. So there's input and output signal. From these signals you can measure like magnitudes, time difference between 2 points, and so on by using the oscilloscopes. Thank you very much, and I'll see you to the next video.